Okay, so yesterday I gave you a bunch of graphs and said, hey, here's some crazy looking graphs. What's the domain? What's the range? Is it a function, right? So see these little yes and no's? We already talked about that. It passes the vertical line test. You may or may not have done that, and that's okay. This is the most important. So from yesterday, I had you guys take these notes, and these notes were going to be the most helpful. So I told you there's going to be 4 things that happen on this next assessment. I need you to know when there's no arrows, what your answer is going to look like. Means when there's no arrows, it means there is a definite left end and a definite right end, and it doesn't go further than that, right? When there's one arrow, it means it's going to go forever in one direction, maybe to the less than direction, maybe to the right direction, but your answer will look like this, which will look like this. It will go forever in this direction, but stop here. Then sometimes there's going to be 2 arrows, and those are kind of the easy ones, because if there's an arrow here and an arrow here, there is no end, there is no stop. This is the opposite of that, right? Here I have 2 endpoints. Here I don't have any. So in that case, your domain and your range is going to, well, your domain for this one is all real numbers, okay? And then there's one where they're not even connected. Those points are just plotted. And in that case, your domain is a list and your range is a list, okay? So what we're going to do today is the opposite of what we did yesterday. Yesterday I said, here's a bunch of graphs. Tell me the domain and range. Today what we're doing is, here's a bunch of domains, tell me the domain and then graph it. We are literally going backwards from yesterday. We're undoing what we did. These are blank. You need to get the graphs on there, and we're going to do that using a 2-step process. So are you ready? Okay, so the first thing we're going to do is label what we're doing. We are graphing a function with a given domain. Okay? And in order to do that, I'm going to give you the domain. I'm not going to give you the range. You have to find the range first. This is really, really easy. You guys commit to 15 minutes with me and you will understand this, I promise. Okay? So here's what today's going to look like. I'm going to give you 2 things. I'm going to say, hey, here's your domain. It's -2, -1, 0, 1, 2. And then I'm also going to give you a function. I'm going to say let f of x equal 3x plus 2. You can't even do the problem unless I give you those 2 pieces of information. This is the function that I want you to graph with that domain. Okay, do you understand our objective? Okay, so in order to do this, I have to do 2 things. First, I have to find the range. We're going to use some fancy substitution here. To find the range, what you do is we make what we call a table of values. And once I have a table of values with a bunch of x's and a bunch of y's, then I just plot the points. Actually, I'm going to make this a 3-step process. So I'm going to break this one down. After you plot the points comes the most important part of this process, is what do I do with those points? Do I put no arrows? Do I put 1 arrow? Do I put 2? Do I even connect them at all? So this is the most important part of this. Decide on your arrows. If any. All right, so let's walk you through this process. So we watched notes one day this week that had to do with a input-output table, right? Remember, did I explain it like the security thing at the airport, right? Did I? Have you guys watched that? Oh, I did the notes with you guys. Okay, so those were on the notes. So when you go to the airport, There's like this belt that you have to go through security. If you've ever been there, you have to put your stuff on. It's like a grocery belt. And then it goes into this machine, and this is an X-ray machine, and somebody's sitting there, and they're looking at all the things, and they're saying, sorry, you can't take this in, you can't take that. And then it shoots your stuff out the end, and you take it, and you put your shoes on, and you go, okay? So what we're going to say is when you make a table of values, first of all, I want you to make 2 tables of values. I want you to make one standing straight up. Sometimes kids will call it a T-chart. Your X is always on the left. Your Y is always on the right. You will also see horizontal charts. Then in that case, your X is in the top and your Y is in the bottom. We also learned yesterday that we call X domain and we call Y range, right? What we're going to talk about today is that X is sometimes referred to as your input, which makes the Y your output. So this is going to make sense in a minute when I do this little airport security example. So if I say to you, hey guys, I need you to graph this function up here, y equals 3x plus 2, but the domain can only be those numbers, the first thing you're going to do is say, oh, okay, I got to put those numbers here then. Step 1. So we are on step 1 of finding the range. Make a table of values. All right, this is where this little machine comes in. The input is what you're putting into this little machine. And let's say my first input is a -2. I'm going to put this -2 in there. And what happens to that -2 while it's inside? Oh, it gets multiplied by 3. Whoops, let's just make that an X. It gets multiplied by 3 and added to it. That's the equation that goes in there. And then, what is the output? The Y value that comes out after you put the X in, right? So the long way to show that is to say, okay, the X value will be 3 times whatever or the Y value will be. And then let's put our first domain in, -2. And then f of x is the same as y, right? So 3 times -2 is -6, and -6 plus 2 means that's -4, and that's kind of a lot of work, right? Okay? Do I have to do that every single time for this and write all that out? I just found that that's -4. No, this is one time where I'm going to say, don't worry about showing your work. You can do some simple calculations in your head, right? So let's do that process again, except this time the input's going to be -1. It's on the belt, it's going in. -1 gets multiplied by 3, which is -3, and then I add 2 to it, and I get what? -1. I need to fill in the remaining values using this process. Are you with me? Okay? 0 times 3 is 0, plus 2. 1 times 3 is 3, plus 2. And 2 times 3 is 6, plus 2. All right, I just did step 1. I made a table of values. Not sure if you can see those. Okay? So there's my table of values. This machine is kind of just a little side note explaining how you get the range. Input the domain, output the range. Now, we have to plot our points. Go ahead.
With that one, will it always go up? 3x would always go up.
I love that Robbie just asked that, because I was actually brought that up at the end of last hour. His question was, I noticed that these are all going up by 3s. Is that always going to happen? And I asked the other hour that, and they had no clue. So he said -4 went up 3, then it went up another 3, then it went up another 3, and hey, that's not a coincidence. And you know why it's not a coincidence? Because that's a 3 right there. So my answer to that is sometimes it will and sometimes it won't. Here's when it will. When your domain is going by 1s. So do you remember last year that Mr. Meeks taught you that your rate of change, slope, all that stuff? He said he touched on it a little bit, but not in depth. We're going to go over it in depth. When your range is going up by 1s, that number in front of your x is what it's changing by. So we really, according to what Robbie just said, as soon as I figure out that first value, do I really even have to recalculate the others? He could just say, okay, it's going up by 3. Let's make that go up 3. Okay? Did you catch that? There are going to be charts that we make that these don't go by ones, though, and then all bets are off. You can't really do it that way. So if you know that this is going by ones, kick those threes out and just go boom, boom, boom. Absolutely. Okay? So your table, if it's horizontal, will look like this. You don't have to do the -1, -1, 2, 5, 8. Either way. Okay. So step 1, find the range by making a table of values. Awesome. I used the domain. I made my table. I plugged things in. I got my range. What do I do next? Let's plot these points. Bless you. So now on my graph, I'm going to plot these points. Well, a t-chart or a table of values is ordered pairs. It's -4, 2. It's -1, -1. So -2, actually, -4. -1, -1. 0, 2, 1, comma, and I'm just eyeballing it. That's all you have to do right now. 1, 5, 2, 8. Here's the deal. They should all be, for today's lesson, in a straight line. Because I'm giving you equations that are linear. So if your points get plotted and you got one point way over here, go back and check your calculations because something's off. They should all line up. Okay, now this is where you stop. I just plotted the points. And now the most important step pops up. Decide what to do with those points. So that's where this comes in really handy. So there's 4 types of graphs. Depending on what my domain can be, which one of these fits? So now I'm covering these up, looking at the red. Was the domain I gave you 2 numbers and a bunch of numbers in between them? No. Was it greater than 1 and the rest in the direction? No. Was it all real numbers? No. Was it just a bunch of points? Yes. So what do I do when it's just a bunch of points? I don't connect them. So I know your first instinct is to get a ruler out and I'm going to connect these because that's what you do with lines, and you do this and you go, woo! But that's not a domain of only -1, -2, 0, 1, and 2, is it? By doing that, you're telling me your domain not only can be these, but it can be everything in between them. So this is one that just stays put. Do you want to know why? Here's why. Because here's your domain of -2, -1, 0, 1, 2. And that's all that it can be. So do not connect the dots. Are you okay on that example? So guess what we just did? Of the 4 different types of graphs, we just did 4. Now let's work on the others. So that's where you're going to get this paper out. Let's just real quick, let's just practice this. There's not a whole lot of space on here for some charts, so maybe you can just fit in right to the right of them. So now here's the deal. X and Y. Number 1 looks like it's going to be a bunch of points that aren't connected. Put the domain right here. Put it -3, 0, 2. Use the input-output device to plug this in. You're putting a -3 in there. And so -3 times 2 is -6, right? But plus a +1 is what? Okay. So -6 plus 1, right? And then put 0 in, and you get what? Now stop. Are these going by ones? Shoot. Can't use that little shortcut, can I? So I can't just go up by 2. Some people are really cool and they do this. Well, what is it going by? So can I just go by 2 3 times? Do you see where I'm going with that? This is kind of like for people who are... So, Rob, you might get this because if this is going by ones, it would go by 2, and I would go up to -3. But it's going by 3s. So I got to go by 2 3 times. So what do you expect this to be? 1. So it went by 6, didn't it? Whatever you feel more comfortable with. If you're like, shoot, that took way too much time, I'm just going to put a 0 in there and do that, you go right ahead. Now I'm going to put a 2 in there, and 2 times 2 is 4, and 4 plus 1 is 5. And now look, does that make sense that only went up by 4? Because this went up by 2, and it went up by 2 twice. Side note, if you didn't get what I just said, don't worry about it. That's end of this unit. Okay, so I just found my range. Let's plot my points. -3, -5, all the way down here. 0, +1, and 2, +5. We're looking good. They're all in a row. Do I connect them? No. You're done. Can I move on? Yes? Oh, except guess what I did? I changed that, didn't I? So we're going to pretend like that's -3. Okay? There we go. No, it matches. Probably wondering why I did that. All right. So, hey, let's move on to number 2. We're right here. So let's make our T-chart. We're doing the same 3-step process. Find the range, plot the points. What do I do next? So now, are you ready? This is actually make or break right here, what I'm about to show you. Your X and your Y. They're giving you a domain. They're saying, I want your graph to go all the way to -4, but not to the left of it. It's got to be greater than it. Can it be -4? Yes. I want it to go all the way to +2, but it can be -2. I should have done, actually, I want to do this one because it's a little bit different. You'll see. So just make this your chart right here, XY. Okay, I want it to go all the way to -3. It can be -3 because that little line right there. I want it to go all the way to 4, but can it be 4? So you know what kind of circle we're going to need there, right? So let's watch what we do. Ready? So important. The numbers you put right here is the most important thing. So if I want it to go all the way to -3, then put -3. If I want it to go all the way to 4, then put 4. Notice what I did. I left a space here. You really only need 2 points to plot a line, but I always like to put one number in between those two just to make sure I'm on point, right? Pun intended. -3, 4, and something in between them. Use 0. 0 is really easy to work with. Okay, ready to do this? So let's plug this in. This is a really good example because of that little negative. Negative means the opposite, right? So that means, hey, whatever X value you're about to put in here, I want the opposite of it. Or if you get confused, look at it like this. And then when you go to put your -3 in there, you see, oh, so they must mean they want a +3, right? And so this is going to be +3 minus 2, which is going to be 1. Do you see why that's 1? Okay, 0 doesn't matter because the opposite of 0, -0 is just 0. 0 minus 2. And then the opposite of a +4 is -4. And then -4 plus a -2 is -6. Are you okay with how I got those points? Okay, step 2 is plot them. This is where you have to be careful though. Because when I go to plot -3, 1, the first thing I'm looking at is right here. Because when I go to plot -3, +1, I need to know what kind of circle I'm going to put. Oh, it can include 3, so I'm going to go ahead and darken it in. Because 3 can be part of my domain. Then the 0, -2, of course, it's part of it. However, can 4 be part of it? No. So when I go to do my 4, -6, I'm going to do this. Right? Okay? So now, the hardest part and the most important part. What do I do with those points? Hey, I'm going to check this. I'm going to see what my domain looked like. Did my domain that I was given kind of look like that? So it means not only can it be -3 and 5, it can be everything in between too. So what should I do with those 3 points? Connect them. Will I put arrows though? No. So then I had a kid say, sometimes I'm kind of sloppy. How picky are you going to get? And I said, very. Like, for example, if they go like this, you're going to get it wrong. Why? Because I'm going to do this. I'm going to put a little X here and a little X here and say, oops, sorry, your domain went too far. You went all the way to -4. You're supposed to stop at -3. And it will count as a conceptual error against you. So when you go and do this, don't be sloppy. It has to stop there. Yes, Alex. If a line isn't even, I am okay with that. I'm not that picky. Yeah. So if you don't have a ruler, Totally fine by me. But I don't want you extending it past that point, because remember yesterday we talked about domain. It has to take place in this highlighted area. And if it's outside of that highlighted area, it's wrong. Okay, are you with me? Okay, awesome. I want you to try number 2. Go ahead and back up and try number 2 real quick. Work on getting your domain filled in correctly. Work on finding out what the range is. Decide what to connect. Go for it. This one was a little easier calculations, right? What's that? In this particular case, x is a variable that is constantly changing based on the domain that I give you. Oh, f of x. That's the function notation. Yeah, that's called function notation, and that's what Unit 3 is all about, and we're going to talk about what that means. Yeah, that does get a little tricky, doesn't it? Right now, f of x just means y to you. It's another way, a way of saying y. Yeah. This 0 here? No. 0 doesn't mean that these symbols decide on the open or closed circle. 0 is always, the points in between will always be solid. Okay, so do you have 1, 5, 7? Okay, when I go to plot them, let's be careful. First thing I'm going to do is look here. I'm going to do all closed circles, right? So I'm going to go to -4, +1, 0, 5, and 2, 7. And we're looking good. They're all in a line, and I do what with them? Connect them, because not only do I want these points, I want everything in between. Do not go past it, okay? I just want to point out, go ahead.
Are you picky about if the points are slightly moved a little bit?
No. And you know what? Especially because, there's no grid lines here, so I'm going to just have to say, hey, you're close enough. Yeah. As long as these are correct, you're good. The plotting them. The one thing that does happen often, and I'm amazed it happens this often in an 8th grade classroom, is the points are plotted backwards. Do you know what I mean by that? Meaning somebody will plot -4, although it doesn't even go down this far, -4, 1. And we know that's backwards, right? Because your -4 is your horizontal shift. So just don't flip-flop those 2 ordered pairs. Those, I don't know. I go back and forth every year whether I count that as conceptual or not. So most of the time, I'll just say, hey, fix this. Okay. I just want to talk about real quick what happens when it's a half. Okay. Everybody sees a fraction and instantly kind of freezes up and they go, oh my gosh, I don't know what to do. Yes, you do. Multiplying by half means taking half of something. So if you're doing your graph, we won't do this one all the way out. If you do 0, 2, and 4, well, would you rather take half of an even number or an odd number? Even, because it's a whole number, right? So then put even numbers here, because these are the ones that you're going to put in for x and have to take half of. So if this is really y, the y is going to be half of x. Well, half of 0 is 0, half of 2 is 1, and half of 4 is 2. So taking a half of something means dividing by 2. Don't overthink it. Okay, moving on. We have 2 more to do. What if it's just points plotted? Then you don't connect them. What if it's a domain like that? Let's do this one next. So this one has 2 endpoints. This one only has 1 endpoint, and the other end goes on and on forever in the other direction. Let's take a look at number 5. Okay, so let's do a T-chart or a table of values for this. Okay, this one's a little different because your domain says, hey, as long as your domain is greater than 3, you're good. Pick whatever values you want. However, You need a point to start at 3. Even though it's going to be an open circle, you still want to start at 3. So whatever number's given, always put it there. And then you know what I'm going to do? The next two numbers greater than 3. Don't go crazy. It's 4 and 5. Don't go all the way to 100 or do whatever because you have a little graph. So do you agree that 3, 4, and 5, I know that 3 isn't greater than 3, but we need it. And we're just going to use an open circle. So let's put 3 in there. 3 plus negative 9 is negative 6. 4 plus negative 9 is negative 5. And then can we use the Robbie trick? That's what I'm going to call it now. Are these going up by ones? Yep. So what number is in front of the x? Positive 1. So these are going to go up by ones because that's what my rate of change is. That is unit 4. And I'm super happy that some of you remembered that. So as long as those are going up by ones, this can go up by that. I have some points. Let's plot them. Positive 3, negative 6. I know I'm a little off the graph. What kind of circle am I going to put right here? Open, because my domain cannot contain 3. It has to be greater than 3. Then I'm going to do 4, negative 5. Closed. Then I'm going to do 5, negative 4. All right. Stop here. You got to figure out what to do. And usually when it's got one end point but the other end goes on and on forever, how many arrows are you going to have? And hey, if you forgot, remember how I said this little piece of paper is so important? Oh, it looks like that? I'm going to have one arrow. You know what the hardest part is? And I've checked kids' tests in my self-paced class. They put the arrow on the wrong end. Where does this arrow go? Well, you need to ask yourself, where on this x-axis are the numbers greater than 3? To the left of 3 or to the right of 3? To the right. So the arrow for this is going to go like that. Got it? And then a lot of times if it's backwards, then I put a little X and say, no, it's supposed to go this way or something. Here's why I think kids did it weird. Because when this symbol was a less than, they assumed less than meant down. But you're comparing it to the x-axis, and these numbers are greater than 3, right? Okay, try number 3. A little bit bigger numbers. Notice that your axes are going by increments of 4. Yeah, that's 4 minus 8x. So there's two ways to look at this. I'll do this first one with you. Somebody said, well, I'm just going to look at it as 4 minus and then do whatever 8 times my first x is. Zero's not hard. And then I'm going to say 4 minus 8 times negative 1 is negative 8. And 4 minus negative 8 means 4 plus 8. That's 12. Another kid just said, that's way too hard. Just do this. 4 minus 8 times negative 1. Well, we know minuses really mean that 8 is negative. So what's a negative 8 times a negative 1? Positive 8. So it's like you kind of skip a lot of work. So when you have a negative 8 times a negative 1, I know that's not a minus, that's a positive 8. So there's your 12. So when I do it this way, this is going to give me what? Oh, I put that in the wrong spot, didn't I? That was when it was negative 1. When that's 0, that's just going to be what? 4. And then negative 2 is going to make that what? Nope, because the 4 is positive. So they're saying take 4 and subtract 8 minus 0. And 8 minus 0 is 0, and 4 minus nothing is just 4. Okay. 0, 4. What kind of circle do I put? Can it be 0? No. Open circle at 0, 4. If you color that in, that's a conceptual error. That will prevent you from getting a 4. Negative 1, positive 12, negative 20, or negative 2 rather, positive 20. They're all in a straight line. This is where people think less than means down, but less than on this axis means everything has to take place this. So what am I going to do with this? Connect it and go arrow this way. Are you with me? Checking to see where you're at. This is a lot. All right, we got one more to do, and it's the easiest one. And it's all real numbers. All real numbers means you choose whatever domain you want it to be, because all real numbers means it can be whatever you want it to be, right? Here's a hint. Keep it simple, right? -1, 0, +1. It gives you a good sampling of some negatives, some positives. So let's do -1 times 2 is -2. 4, and then go by this rule of it going up by 1. This should be 6. Okay? -1, +2. 0, 4, 1, 6. We're good to go. What do I do here when it's all real numbers? There are no restrictions. You don't have to stop on the left. You don't have to stop on the right. So this is what? All real numbers means put 2 arrows on those ends, because you do not have to stop and make that line nice and long. There you go. Are we good? Okay. Does this help clear up a little from yesterday? Okay, because now the main point is whether I give you the graph first and then ask you for the domain. Hey, here's some crazy looking graphs. What's the domain and range? Or here's the domain and range. Give me the graph. Can you do it? Okay, that's kind of the whole point of 3.